When enterprise engineers build cloud retail systems, they expect flawless infrastructure. But deploy those always online architectures into emerging markets, and the system physically breaks down. Standard software as a service assumes continuous high-speed internet and high-spec hardware. In large parts of the world, those are luxuries, not baselines. Look at the ground reality of retail in Ghana. Small to medium businesses operate at incredibly high volumes, with massive product density, managed entirely by manual labor. Operating at this scale without digital tracking creates a massive vulnerability. Shop owners lose money silently every day because their entire inventory and sales ledgers exist only in notebooks, on calculators, or entirely in a cashier's memory. Solomon Union grew up watching this specific problem in the northern region of Ghana. He founded Rootech IT Solutions to build technology mapped directly to these local realities. Fixing retail operations in these environments cannot be solved by simply deploying Western software. It requires a complete first principles architectural rebuild. The result of that rebuild is the Venta Suite, a commercial product ecosystem designed specifically to bypass these infrastructural bottlenecks. The suite is engineered to operate seamlessly through intermittent internet drops, run on low-spec hardware, process mobile money payments natively, and accommodate multilingual staff. Behind the accessible pricing and simple interfaces sits a highly secure, multi-tenant infrastructure. We are going to deconstruct the Venta Suite's technical stack to reveal how this software physically enforces data integrity and operational scale under extreme environmental constraints. The core retail engine of the entire ecosystem is Venta POS Desktop. It is built on raw PHP and a MySQL database. The hardware requirements are deliberately low. It runs on Windows, Linux, or Mac, requiring only 4 GB of RAM and solid-state storage. The central security philosophy behind the software is enforcing absolute accountability at the checkout counter. To achieve this, the system uses tamper-proof stock control. The software permits 0 manual adjustments to inventory levels. Every single change in stock volume must be tied to a documented, system-generated source, like a purchase order, a goods received note, or formally recorded damages. This strict enforcement creates a continuous, fully traceable log for every transaction and inventory shift. By removing human data entry from inventory adjustments, the system creates a bank-ready ledger that functions entirely offline. Desktop machines work perfectly for fixed counters, but scaling operations to a dynamic restaurant floor requires mobile form factors, like tablets or rugged Android devices, without sacrificing processing speed. This diagram shows the architecture of Venta Mobile. It uses a Flutter framework for the UI, wrapping around an offline-first SQLite database. Rather than querying a remote server, all catalogs, categories, and active sales data are replicated directly onto the local device. This localized data structure guarantees zero-latency transaction processing. The app remains responsive, unaffected by network drops or slow internet. When the connection temporarily severs, a persistent background sync engine captures and holds all offline transactions locally in a secure queue. The exact moment connectivity is restored, the engine silently pushes the transaction payload up to the Venta Cloud API. Venta Mobile is not a thin client relying on the cloud. It is a highly resilient node capable of surviving complete network isolation. Tying these localized nodes together is Venta Hub, a centralized Django-based cloud dashboard that acts as the connective brain for the entire suite. In busy hospitality environments across Ghana, waiters need real-time table status updates. At the same time, they rely heavily on mobile money, or MoMo, which operates on third-party financial rails. This flowchart illustrates the payment loop. When a customer is ready to pay, a waiter uses Venta Mobile to initiate a MoMo request. The app fires a digital request through the Paystack API directly to the customer's phone. An automated SMS bill arrives on the customer's device. The customer reviews it and approves the transaction via their personal mobile wallet. Upon approval, Paystack instantly fires a webhook payload to Venta Hub, confirming the funds have cleared. Venta Hub immediately pushes that state change back down to the local Venta mobile device. The digital floor plan updates in real time, flipping the table visual from an occupied red to an available green. This architecture elegantly bridges asynchronous third-party payment systems with real-time local state management, ensuring zero discrepancy between the active restaurant floor and the cloud ledger. Hardware and software can be perfectly engineered, but deploying complex API and security tokens to remote locations with no dedicated IT staff presents a massive logistical hurdle. This diagram details zero-touch provisioning. Instead of manual entry, the system uses a single YAML file. Administrators send this via WhatsApp, the cashier imports it, and the software instantly populates store profiles, API endpoints, and cryptographic tokens. At login, the app locks itself to the exact hardware identifier, the device UUID, of that specific tablet. This creates a hard physical boundary that prevents unauthorized users from cloning the software license onto personal devices. Once running, automated crash telemetry continuously monitors the software. It silently packages error tracebacks and emails the Rootech support team before the shop owner even notices an issue. High-end cryptographic security and complex device configurations are handled entirely programmatically. This removes human error and technical friction from the end user. Because the foundational data layer across the point of sale, mobile apps, and Cloud Hub is strictly immutable and locally resilient, Rootech can safely attach advanced commercial modules via API. VenGO acts as the automated e-commerce arm. It pulls live inventory and pricing directly from Venta Hub to generate an instant online catalog for the merchant. Venvoy coordinates last-mile logistics. It tracks delivery riders and uses webhooks to reconcile delivery fees straight into the merchant's financial records in Venta Hub. Beneficious handles customer loyalty. It is baked directly into the checkout flow, meaning cashiers can issue and redeem points without requiring any secondary scanning hardware. These 6 distinct products function as a single, frictionless ecosystem, specifically because they share the exact same contextual engineering standards. This modular architecture scales financially with the business itself. It runs seamlessly from a low-cost LITE setup for a single market stall up to a fully managed enterprise tier supporting multi-branch chains. Automated telemetry, multi-tenant databases, and offline first syncing are no longer restricted to corporations with massive IT budgets. Technology only solves problems at scale when the software is engineered from the first line of code to respect the physical and infrastructural realities of the ground it operates on.